Good morning or good afternoon, everybody. Thank you for joining the live webinar today on the topic of successful wireless gas detection applications for oil and gas. My name is Stephen Tsao, your host and moderator for the day. Any feedback or comments regarding this webinar are greatly appreciated. Joining us today are two expert speakers. The first one is Michael Weinstein, Senior Global Product Marketing Manager for Portable Solutions, and Jan Banducci, Senior Global Product Marketing Manager for Fixed Solutions. They will walk us through successful applications they have seen and how these examples are setting the bar for real-time detections with advanced detection solutions. Before I turn it over to Michael, I do have a couple of housekeeping items. All attendees are automatically muted to minimize background noise. Please remain muted for the considerations of others on the call. Now let me show you how to submit questions and comments. In order to provide your feedback or to ask a question during the live session, please go to the WebEx toolbar or the WebEx logon page and click on Chat. Type your questions in the open text box and make sure you send it to Stephen Tsao, which is myself, and we will compile and consolidate your questions. Likewise, you can also email us at events@raesystems.com, and we will try to answer as many questions as possible at the end of the webinar today. And if there are still outstanding questions, we will get back to you with a response. This webinar is scheduled for 60 minutes. Please feel free to type in your questions at any time during the webinar, and the Q&A session will be held at the end of the event. So let me quickly go through the agenda that we're going to be going over today. We're going to talk about confined space entry, lone worker safety, oil and gas exploration, and refinery turnaround. And as mentioned previously, we will end with a Q&A session. Just another quick reminder to please keep your microphones muted. And at this moment, I'd like to introduce Michael Weinstein, Senior Global Product Marketing Manager, to kick us off. Good morning, Michael.
Morning, Stephen. Thank you very much. Morning, ladies and gentlemen. Appreciate your joining us today. And really, the purpose of this webinar is to illustrate how wireless has been revolutionizing gas detection by providing the real-time visibility into the atmospheres that may be hazardous for workers, and giving the safety officers the ability to get better tactical awareness and respond to potential incidents faster. The first application we're going to look at today is confined space entry. I'm sure that all of you are familiar with the confined space entry because the confined spaces are really widely present in a lot of different industrial environments. And when talking about the oil and gas industry, whatever application you look at, upstream or downstream, really the confined spaces are all there. So pardon me for 1 second. I will take control of the presentation here. Thank you. So just to give you a quick reminder of how confined spaces are defined by OSHA. So that's covered by OSHA Standard 29 CFR 1910.146. So a confined space is large enough for a person to enter and perform assigned work in. It is not designed for continuous occupancy. And it has a limited or restricted means of entry or exit. That's why it's confined. But the type of confined spaces that is of a particular interest to us for this webinar is permit-required confined spaces. So according to OSHA, the difference that the permit-required confined space brings compared to a regular confined space is that a permit-required confined space can contain or has the potential to contain a hazardous atmosphere, right? And that is very relevant to our today's topic, right? So gases, whether toxic or combustible or oxygen deficiency or enrichment, are the potential threats within a permit-required confined space. Now, a permit-required confined space may contain a material that can engulf someone who enters the space. It may have a configuration that may cause a person to be trapped in it. And it may have other recognized serious safety or health-related hazards. Right, so permit-required confined spaces is what we're going to focus on today. And we're going to see how wireless is making entry into permit-required confined spaces safer. Now, let's take a quick look at the participants, people involved with a confined space entry into permit-required confined spaces. So there is a person actually doing the entry and performing some kind of work inside a confined space. Then there is an attendant who is directly watching that person. And there is an entry supervisor who is responsible for the entire process. Now, here are some duties that different participants in a confined space entry have to fulfill according to OSHA. So these are just select duties. There are big lists of duties that OSHA outlines for each of the three types of participants, but we're going to focus on those that can be simplified, improved during using the wireless technology. So one of the things that the entrant has to do, according to OSHA, in addition to the actual work that they do inside a confined space, is to maintain communication with the attendant, to inform the attendant of the status of the person performing confined space entry, and to enable the attendant to make decisions related to whether it's safe to proceed with confined space entry or it's necessary to evacuate. Now, in case the entrant witnesses a changing situation inside a confined space, determining that a condition may exist that can later become dangerous, or the physical condition of the entrant changes to worse, then the entrant is also supposed to notify the attendant. The attendant, on the other hand, maintains communication with the entrant, and if there are multiple people involved with confined space entry, the attendant keeps the account of who is entering that permit-required confined space. Then the attendant orders evacuation and summons rescue in situations where a prohibited condition exists, an atmosphere changes to a dangerous atmosphere, as recognized by OSHA in the standard operating procedures at a facility. The attendant orders evacuation in case a worker displays signs of physiological effects of an exposure to hazards. And the entry supervisor, in addition to a lot of other responsibilities that they have, really watches the entry and makes sure that the entry happens according to the original permit, right? So the entry supervisor makes sure that the conditions of the confined space entry remain acceptable throughout the process of confined space entry. Now, there is a very important question that remains in regard to how do the attendant and the entry supervisor who remain outside a confined space, how do they find out that, for example, a prohibited condition or a hazardous atmosphere emerges inside a confined space. How do they know, for example, that the worker is down, right, or shows signs of physiological effects of hazardous exposure, as OSHA defines it? How do they know that acceptable entry conditions are maintained throughout the process of confined space entry, right? And what we're looking at here is really gas detection-related hazards, as well as man down, as the condition of the entrance. There are some things that we're not covering in this webinar because this is a webinar about gas detection, so we're looking at the conditions of the atmosphere inside a confined space. There can be a lot of other factors that may make the conditions of confined space entry unacceptable. But we're focusing on toxic and combustible gases as well as oxygen deficiency or enrichment. Now, so the old ways, the common ways of the attendant and the entry supervisor to get the information about the conditions of a confined space is really to rely on the entrant to communicate all that information back. So as it pertains to gas concentrations, for example, the entrant would be required to look at the monitor with a certain periodicity and then communicate the readings from the monitor of the concentrations of toxic and combustible gases and oxygen inside the confined space over a walkie-talkie to the attendant or the entry supervisor. Now, there are some potential issues with this approach as they pertain to safety and ability of the entrant, the ability of the attendant or the entry supervisor to react to changing and potentially hazardous conditions quickly. The reason for that is neither the attendant or the entry supervisor know directly and immediately what is going on inside a confined space or what is happening to the entrant. They rely on the entrant to obtain that information. And so in case, for some reasons, the concentration of a toxic gas or a combustible gas or the oxygen itself inside a confined space changes, they will not know about it unless the entrant reports it. What happens if an entrant has been overcome? So the attendant or the supervisor would not know that until the next planned communication session. That is not going to happen because the person is not overcome. And so it may be too late. Now, even if everything goes well, the entrant doing work inside a confined space, which is the reason for that confined space entry, would have to distract him or herself from performing that work in order to be able to periodically report back to the attendant on what is going on inside that confined space and let the attendant know that everything is okay. So there are some inefficiencies with this process, with the current way of doing it. And in some ways, it has inherent limitations in terms of the ability to deliver help to the entrant quickly. Now, a better way that is used currently is for the attendant to use another instrument, a redundant instrument, to monitor the confined space in order to be able to directly get first-hand objective information on the condition of that confined space, the atmosphere inside a confined space. And there are a couple ways in which this is done. There are some legacy instruments that allow the attendance instrument to directly communicate to the entrance instrument over a cable. So the entrant is physically tethered to the attendant. The entrance instrument is connected to the attendance instruments with a cable. And the attendance monitor really shows exactly the same readings as the entrance monitor shows, so that the attendant is aware firsthand of what is going on inside a confined space. Another way is for the attendant to have his or her own instrument that has a sampling line that goes straight inside that confined space, so that the attendant's instrument is not tethered to the entrance instrument, and the attendant gets objective information on the condition of that confined space by drawing a sample from that confined space. So there are some potential problems with that, because if it's a stratified, if it's a tall confined space, then the attendant may not exactly know the level on which the entrant is physically located, and since the gases, different gases, potentially hazardous inside a confined space, can be present at different levels of that confined space. And then the attendant may be monitoring from a wrong level of a confined space, from a different level where the entrant is, and there could be a danger at the entrance level of the confined space, and it could be all clear at the level from which the attendant is monitoring. So there is no guarantee that the attendant will be monitoring gas concentrations from the right strata of that confined space. Now, also there is a limitation of this approach, because the attendant has to have an extra or a redundant monitor, and it's a gas monitor. We all know that the gas monitors may be costly to acquire, and they require maintenance, right? You need to bump test the gas monitor prior to each day's use. You need to calibrate it periodically. You need to replace sensors. You have spare parts to worry about. So it is another monitor to maintain. So this way is a better way, because the attendant is immediately aware of what is going on inside a confined space. The attendant does not rely on the entrant to communicate that information. But there are some inherent inefficiencies because of, related to this process, because the attendant can be monitoring from a wrong part of the confined space, and the attendant has to have his or her own redundant monitor. Now, keeping that in mind, in some cases, even with the new wireless approach to confined space entry, it may be beneficial for an attendant to have a second monitor, right? Because if it's a stratified confined space, and for example, if the attendant needs to be able to get information from the entrance to that confined space, for example, for rescue workers to be able to enter and make decisions on their personal protective equipment, in that scenario, it's very beneficial for the attendant to have a second monitor regardless. But let's look at the new way. A lot of our customers have discovered the benefits of wireless to be so significant for the confined space entry, for the improvement of safety related to permit required confined space entry, that this is their standard operating procedure. So instead of using a regular multi-gas monitor, an entrant has a wireless multi-gas monitor that has a wireless modem inside. So this way the monitor wirelessly transmits its readings and alarm status to a portable mini controller, a wireless device that shows the attendant the real-time readings and gas concentrations of the entrance monitor. Now, keep in mind that the wireless monitor transmits continuously, and it also does so automatically, so the entrant does not even need to worry about making sure the attendant knows the gas readings inside a confined space. So the attendant's EchoView host mini controller, that you can see in the picture, shows real-time gas readings and alarm status from the entrance monitor. And by the way, if there are multiple entrants, the EchoView host can display readings and alarm status from multiple monitors, up to 8 monitors at a time. And that mini controller has its own alarm, an audible alarm. It has alarm lights as well to attract the attendant's attention in case the entrance instrument goes into alarm. So what are the elements of this solution for the entrant? And if the attendant uses a redundant gas monitor, the solution includes a wireless multi-gas monitor, such as the Multuri family of wireless multi-gas monitors. These instruments have not only the built-in wireless capability, they also have the man-down alarm. And the man-down alarm activates in case the entrant is not moving for a certain period of time, and while the entrant is supposed to be moving and performing work. So the instrument assumes that the entrant is down, the person is down, the person has been overcome, and provides the person notification. asking if the person is okay. And if the person says, yes, I'm okay, then the man down alarm does not activate. But if the person does not say, yes, I'm okay, or says, no, I'm not okay, the man down alarm activates, and the attendant knows about it immediately. So the attendant and the supervisor can have their own mini controllers, the EchoView hosts, as we call them, and these mini controllers would display information from multiple instruments, like we talked about it, and they can be at significant distances. And the distance of 660 feet, that typical distance, it is going to be less than that in case the signal has to go through metal, but it would stay sufficient for most confined space entry, even if the confined space is actually a metal or a steel structure. So to summarize the new wireless way of doing confined space entry, what are the key benefits to you? Better safety. Wireless elevates safety because it lets the attendant and the entry supervisor know immediately if a hazardous condition or a hazardous atmosphere emerges inside a confined space, so that the attendant can summon rescue or order evacuation sooner, which can potentially save the lives of the entrance and the assets, preventing an explosion, for example. Now, better productivity of workers performing entry because they can focus on their work rather than having to continuously read the gas concentrations over a walkie-talkie of their gas monitor. Now, wireless offers a tether-free connection which improves the agility of the entrant inside a confined space. So the entrant may not be tethered to the attendant. And of course, the lower cost. The EchoView mini controller is virtually maintenance-free. All it requires is a periodic battery replacement, and the battery lasts 10 days, 24/7, which is unlike a second redundant gas monitor, which requires maintenance, sensor replacement, calibrations, etc. So the wireless way of performing permit-required confined space entry delivers better safety, greater productivity at a lower cost. So the next application I would like to discuss is the safety of lone workers. And lone workers are people who do their work without having other people in immediate vicinity. So they do work unsupervised, but there may, in addition to that, there may not be any person around to help out or call for help in case something happens. So work hazards that lone workers experience at a facility include all the typical work hazards at a refinery: physical, environmental, chemical, electric, falls, etc. But they also have nobody around to call for help in case the lone worker has been overcome. So how is safety monitoring of lone workers done these days? So it usually involves a multi-step program to make sure that the lone worker is okay and does the work safely and returns home every day. So that may include the supervisors periodically going out and physically visiting the people that work alone to make sure that everything is okay. Then they could maintain a pre-agreed interval, pre-agreed schedule of regular communications that occur between the lone worker and the supervisor or the safety officer at the command center. For that, they would use either phones, if it's safe areas, or walkie-talkies, intrinsically safe walkie-talkies to communicate if it's a hazardous area, or both, depending upon the area classification at a refinery, for example. Now, the people at the command center and the supervisors can use warning devices that can trigger alarms in case no communication from a worker working remotely has been received. And there could be also a system implemented that ensures that a lone worker has returned to their base after completing his or her job. All of these measures are valid. They lack one thing. They are after-the-fact measures. In case something happens, there could be a prolonged period of time that people at the remote command center and or supervisors may remain unaware of an incident or an accident or a person being down. So that gap is resolved by adding wireless to the loop. And the way it works is very simple. A lone worker has a wireless gas monitor that is equipped with a man-down alarm, in addition to the walkie-talkie, of course. So the monitor is accompanied by a portable wireless modem, Raylink branded products, and the portable wireless modems actually have a GPS radio in them. So they deliver a very precise geographic location of that worker within the facility. So in addition to transmitting the signal from the wireless gas monitor at distances up to 2 miles, the modem provides accurate location-based information. So the gas readings from the monitor, the alarm status from the monitor, including the man-down alarm, and the GPS coordinates of the radio of the wireless remote modem are transmitted to a remote command center or a supervisor in real time. So that transmission, like we've seen it in the confined space entry example, is done automatically without any involvement from the worker. Now, a safety officer at a remote command center proactively monitors the readings of the worker's gas monitor. And in case the readings go up or down for oxygen, for example, then that person at the command center can proactively initiate a communication with the lone worker in order to be able to instruct the lone worker of a changing environment and give specific steps that the worker should follow to remain safe. And of course, if a person is down, the man-down alarm on the device activates, sends the signal to the remote command center immediately, and the safety officers at the remote command center can summon rescue very quickly. So the elements of the new wireless solution for lone worker safety include the wireless gas monitors, both single gas and multi-gas, accompanied by a portable modem that, in addition to being able to transmit the signal to the remote command center at distances up to 2 miles, provides accurate GPS-based location information to the remote command center, and the remote command center that runs the Ray Systems ProRay Guardian real-time wireless safety system software that can overlay the location of the remote worker on the map of their facility, the custom map of the facility, so that they know exactly at each point in time where the worker is located within a 15-foot range, within a 5-meter range. It's so accurate. So what are the benefits of a wireless-based lone worker safety solution? The key benefit is enhanced safety, where the personnel at the remote command center or the supervisor of that lone worker know immediately if a hazardous condition occurs or a worker has been overcome. This way, help can be dispatched quickly and lives and assets can be saved. Now, better productivity. The worker does not have to report the readings of the gas monitor that he or she carries. This is all done automatically by the monitor wirelessly, so the worker can focus on the work he or she is doing. Now, the supervisor and the person at the remote command center can spend less effort and less time communicating with the worker just with the purpose of obtaining the information on the condition of the environment, of the atmosphere where the worker works, so that they do not have to request the worker to communicate gas readings from his or her monitor on such a frequent basis, because they have the visibility into it continuously in real time. So the Lone Worker Safety Solution delivers improvements in safety and better productivity of lone workers and their supervisors while the workers are performing work at remote locations of the facility. With this, I'm going to pass it back to Stephen so that Jan can cover additional applications, wireless applications in the oil and gas industry.
Thank you for the application examples, Michael. At this moment in time, I'd like to remind the audience to submit your questions via the WebEx chat box or to the email address events@raysystems.com. I want to also note that the recorded session of today's live webinar will be archived on our website shortly after the presentation is over. And I will send you guys emails to make sure that you are alert that the recording is now available. I will now turn the mic over to Jan Venducci, Senior Global Product Marketing Manager, to continue with the webinar. Good morning, Jan.
Morning, Stephen. Thank you. So hopefully everybody can see my screen. My name is Jan Venducci. Again, I'm a product manager for fixed and mesh detection systems. Today I'm going to give you a few examples, particularly for upstream oil and gas and also for refinery turnaround applications. So I'll go ahead and get started with the oil and gas exploration example. And we've been seeing a very large and very rapid uptick in adoption of wireless systems, particularly in onshore drilling rigs, well workover rigs, and completion rigs. There's a quick picture and an example of what we're looking at. Typically, a rig would install several wireless gas detectors around the facility, where workers would be located, and then they all report back to a controller that's located typically in a safe environment, whether it's the doghouse or somewhere else on the pad. So we'll get into a little bit more detail. So really, what's driving the adoption of wireless gas detection, and it really has to do with new technologies. So for one, the low power mesh radios that are relatively new to the market. One of the big advantages is that there's a mesh topology that's used, which allows the detectors to not only talk to each other, but also to the controller. And what that does is it creates a wider footprint and a larger wireless coverage for all the detection equipment. There's also some advancements in batteries. So many of the detectors use a primary lithium cell, which allows the detectors to run continuously for 6 months. That includes the detection and the data transmission of the radio. So a really incredibly long lifetime really adds to the ease of maintenance and the ease of deploying these systems. Another advancement is kind of the lightweight materials. So there's a lot of newer plastic and rubberized materials that are suitable for outdoor environments, very harsh environments, particularly on drilling rigs. They allow for IP65 NEMA 4 for water and dust protection. We also have offered optional stainless steel housings, particularly if anybody's been in a rig environment. There's a lot of moving pieces, and equipment typically is often broken. So we offer a stainless steel housing to just another extra layer of mechanical protection. And then the final, probably the most important piece, is the safety certifications. So in the past, people have traditionally used fixed head gas detection, which take some effort and some significant knowledge, typically by an electrician, to install those fixed head gas detection systems. They would do that because they are certified for intrinsic safety, meaning that they're available to be used in hazardous environments. They're not going to cause a spark. They're not going to make anything explode or put anybody in danger. So with recent advancements, again, with the low power radios and the different materials, the detectors, today's detectors are certified to the same level of intrinsic safety as traditional fixed head systems. And that's Class 1, Division 1, Groups A, B, C, and D. And essentially, what that really means is that these detectors can go anywhere on a rig. You don't need to worry about how close am I getting to the hazardous area. With those types of certifications, they can literally go anywhere on a rig. The other thing that's new is that traditionally radio silence has been required for drilling operations. Typically they have blast caps, or when they're using blasting caps, There's always a concern that some radio interference may trigger a blast cap inadvertently. However, with newer low-power radios, there's no chance of those ever inadvertently detonating a blast cap. We've done extensive third-party testing. We make that available to a bunch of people upon request, and that blast cap testing is a key component in ensuring the safety of the system and that and making sure that we meet all the regulatory approvals required in the drilling environment. Okay, so that's a little bit on the detector side. When those detectors, once they are out deployed, they need to report their data back to a centralized location. There's several different types of controllers designed for use in safe areas. The first type of controller is a dedicated system controller. Typically consists of a large graphic display. They support multiple detectors. Inside of these boxes, there are 5 programmable relays that can be used to trigger lights, horns, other alert notifications. We've even seen some people use them for process control that they need to immediately shut off part of their process. They can use the relays inside the dedicated system controller. And also, typically these controllers have various forms of data output. So they have Modbus output, which is the traditional, more traditional way of outputting data. They also have Ethernet output, meaning you can push that data to a network, through a network. And I'll talk a little bit more about that in the upcoming slides. The other type of controller that we have seen some adoption on is the PC-based controller. So essentially it enables the use of a standard Windows PC as a system controller. Our particular software is called ProRay Guardian. It's really a command and control. It monitors all of the relevant data and alarm conditions, as well as keeping track of the historical data. It supports, again, multiple detectors, and it also has serial and Ethernet outputs. One of the big advantages of a PC-based controller is that the PC is capable, obviously, of doing a lot of different things in addition to monitoring the safety detection system. So once the data is on the computer, you have a lot of flexibility in what you want to do with that data and how you want to share it with other interested parties. So one of the big advantages of having a wireless gas detection system is that you can have extreme flexibility for the rig. So wireless systems provide the maximum versatility. You can use LEL and H2S heads at the seller location, LEL and H2S heads at the shaker, SO2 at the flare pit, and then a lot of times we see H2S on the fence line to monitor the footprint. And this is just one particular example of this rig. The real point here is that because they're wireless, because they're extremely portable, they can be deployed in any fashion that's necessary, and they can be easily moved and rearranged as required. One of the particular interesting ones that we've seen is the fence line monitoring application, particularly where there is drilling activity going on in close proximity to residential neighborhoods. So we see that oftentimes the residential folks are clearly interested in what's happening on the drilling site, and sometimes they might smell some nuisance smells, typically from H2S, which has the odor of rotten eggs. So what we can find for people, what we see from the drilling sites is they want to know exactly how much, exactly what's coming off of their footprint in order to better inform the community around them to say, we understand that there's some nuisance smells, but we have data showing that it's not at any harmful levels. And again, we see that when the wind changes, they need to rearrange some of these detectors. And so with the wireless capabilities of the detectors, that's very easy to do. They can either add, move, or subtract detectors as necessary all over the drilling site. So the other key important factor of the wireless system is that it's really truly a turnkey system solution. So wireless systems in general are compact, lightweight, and easily transportable. You can see in the graphic there the entire system. This is an 8-point detection system, fits in a Pelican case. It's roughly 3 feet by 2 feet wide. So it's one person can easily set up and deploy an entire system. And that system can be deployed in less than 30 minutes with no specialized training. It's literally power on the detectors, power on the controller, and you'll see all the relevant data in one place in real time. It also provides continuous detection and data transmission for months at a time on a single battery. So I spoke about that a bit earlier. But again, it's up to a 6-month continuous runtime on a single battery. So that's 24 hours a day, 7 days a week, continuously transmitting that data in real time back to that controller. And then finally, they carry the same hazardous location certifications as traditional fixed heads. So you gain all the flexibility of wireless deployment, but you're not losing anything on the certification side. Okay, here's a couple pictures from some applications we've seen. This is a picture we've seen of detectors being deployed in a Class 1, Division 1 hazardous area. Again, you can see the drill hole and the detector going, within a few feet of that. Again, the detectors are Class 1, Division 1, meaning they can essentially go anywhere on a rig. Another quick application picture. Here's some folks, some safety personnel that are looking at a controller in the non-hazardous area. This happens to be in Bakersfield, California. You'll see that on their controller in the picture there, they are using the internal relays to drive different lights and a horn. And that alerts the folks that there's any type of condition on the rig that you see in the background there of the picture. Okay, so once the data is transmitted from the detectors back to the controller, now what can I do with it? So that scenario is great if I'm within close proximity of the controller, or if I have, as we saw in the previous picture, if I have various alarms connected to my controller. But we can do better than that. We think we with today's technology and the way the networks are expanding rapidly, we've enabled our controllers to output that data and be able to share that information in real time across the network. So the controller, like I mentioned before, has both Modbus output that can go to a standard PLC, an existing PLC, or we have an Ethernet output that can be put directly onto a network, and that data and those alarm conditions and all of the historical information from those safety systems can be viewed in remote software. The other thing this allows you to do is to bring in outside experts. So as Michael mentioned as well, so not only do you have the historical record and you have that real-time alert, if something were to happen and you needed to bring in an outside expert, you can do it in near real time with the software solution. Call up the person on the phone and say, hey, would you take a look at this? Tell me what you think is going on. And that can all be done within a matter of minutes as opposed to the traditional way of getting on the phone, re-describing the entire situation, presenting them some data files. So your time to respond is greatly increased using a network solution. Just another kind of quick example of how the data can be shared. We looked at the drilling example. So we often see that the data that's being recorded from the drilling sites is being sent back to a divisional office. The drilling sites are typically in remote locations, and the divisional offices of these safety companies or the drilling companies are often not in close proximity to the drilling sites. So all the data from the drilling site can be sent back to the divisional office. But in addition, multiple drilling sites spread across a wide geography, anything that has a network. It could be some units in Texas, some units in Pennsylvania, some units in California. All that data can be sent to one divisional office. And if you take it one step further, if you have multiple division offices, so one in Texas, one in California, one in Pennsylvania, all those guys can be aggregating their own data and track all their information in real time. But all of that information can also be rolled up to a corporate office. So you have somebody in Houston who is managing the entire, responsible at a national level for safety information and safety compliance. All of that data can be rolled up and aggregated in real time at the corporate office using the networked solution. Okay, so that's it for the upstream example. The next example I want to talk about quickly is the refinery turnaround applications. So just a quick real-life example, a major U.S. oil refinery in New Jersey has recently used up to 33 wireless gas detectors for area monitoring during their plant turnaround. So during the turnaround, typically refineries will shut down certain processes or certain equipment in order to perform routine maintenance on those particular areas. So 2 reasons why the continuous gas detection is necessary during the refinery turnaround. The first one is safety. So while workers are performing that routine maintenance, that area needs to be monitored to make sure those workers are safe. They want to make sure that indeed that process is no longer emitting any type of harmful emissions. And also you want to make sure that some other area that has not been shut down, that the emissions from that area are not blowing into the area where the workers are. So that continuous monitoring is really a key safety element of the turnaround. And by using the 24/7 gas monitoring, there's significant time saved by not having to recertify confined spaces for each work shift. So in a traditional model, what we had seen is one shift of workers would be working. When they leave and a new shift comes in, as soon as somebody leaves that area and then they want to come back, or the next shift wants to come in and continue working, that area, if there's not continuous detection there, needs to be recertified, typically by the industrial hygienist or somebody else with some training to say this area is safe for these people to work in. And so if you have continuous detection, you don't need to recertify the area to continue performing work. Okay, so what equipment are these guys using for the continuous monitoring? So they're using a product, a multi-gas detector that has been field-proven multi-gas and radiation detection instrument. They can choose up to 5 internal sensors, any of the toxic gases, flammable gases, radiation, oxygen, broadband PID detection. All of those can be enabled inside of one detector. The detectors you can see in the graphic there, it's got a large antenna that's coming off of it. It has an embedded license-free radio. So it's a bit different than the mesh technology we just talked about on the drilling side. This is a frequency hopping spread spectrum technology radio, and it transmits at a higher power, but because of that higher power, you can go up to 2 miles away from your controller and still receive all that real-time data and alarm notifications. The other advantage of having this particular system is the detectors have optional GPS. So a lot of times in a refinery situation, the detectors are outdoors, and by using GPS, not only are you tracking the data and the alarm conditions, but also the location of that detector. So all that, every time that a data packet gets sent, it has a location stamp along with it. So retroactively, when you're looking through your data log, or if you need to run reports, it's very easy to tell where that detector was located, when it went into alarm, or when it detected certain levels of gases. In addition, this particular detector is, you can see in the graphic there, is made of ruggedized stainless steel. It has the same IP65 rating, NEMA 4 equivalent, so it's built for outdoor use in harsh environments. So what did this particular refinery need? So at the time, the refinery needed to be able to rapidly deploy 24/7 gas detection at multiple locations throughout their refinery. Each deployment was going to last between 3 and 7 days based on the particular process. And the specific gases they needed to detect were CO, H2S, NO2, and O2, all of those at separate locations. So you can kind of see in the graphics that the refinery is relatively large, and the bottom right-hand picture there is a solar solution that is also provided. So that enables the detector to go from a 24-hour battery life to an indefinite battery life. So in some of their applications, they needed up to 7 days, and they didn't want to have to swap batteries in the particular detector. So they opted for a solar solution, which really reduced their maintenance overhead. Okay, the facility has 6 independent wireless gas detection networks that are linked to a local control room. So the big question for these guys was, how do we get the data from all of our gas detectors onto one screen? They have one safety personnel at the top of the ladder who wants to be able to view all of the data in real time. So here's kind of a quick layout of their facility. They set up, as you can see in the graphic, 6 independent gas detection systems. So that's 6 controllers with roughly 5 to 6 detectors on each controller. So now not only the local process safety personnel was informed in their localized area, but all that data is run over a network through the software, and it goes back to their master control room where the safety manager can view all 6 of those different processes and alarm and notifications all in real time. In addition, it really helped. One of the big drivers for this particular application was the aggregation of that data. So when it came time for the safety manager to write his reports, all of that data is already aggregated in one place. So they're all time-stamped. Everything is monitored at one time in one place. And when it came time to submit his reports at the end of the turnaround, the software facilitated that and saved him, hours and hours of time that he would have normally had to spend gathering data from different locations. Okay, so data from each of the 6 control rooms, again, was pushed to a central computer using the software. The facility manager had access via the internet, and the data was available from any other computer that has internet access. So one of the functions, not only the safety manager aggregating all that data, with a username and password, he can allow anybody else in the facility to log in just using a standard browser and log in and view all that data and all that historical information all in real time. So multiple people at the refinery were viewing the data in real time. A quick screenshot of what the software interface looks like. You kind of see the big graphic in the middle of the screen is the facility layout. You can see that their detectors are placed on top of that layout. You can see it's very on the bottom of the screenshot. You can see there's a very simplified red light, green light alarm notification system. So green light obviously means everything is fine. Red light happens when there's an alarm condition, and that you would see that there's a large icon that shows up on the screen. It beeps. The computer makes lots of noise. Because it's a network solution, it can also send text messages upon alert notification. It can also send emails to interested parties based on what the alarm notifications are. So you have a lot more flexibility, obviously, with the software. In addition, you can see on the right-hand side is a running chart of the historical information. Again, the software is data logging everything that's coming into it. So for any reason, something happened on the previous shift or it happened 3 or 4 days ago, you can always come back to the software and easily access the historical information from any of those detectors that are on the network. Okay, so this is my final slide and just kind of a quick wrap-up. So I know we talked about a lot of different applications, and the point we want to get across is that wireless gas detection systems for oil and gas are expanding at a very rapid rate, and we see a lot of oil and gas customers adopting them for various reasons. One, for increased safety, the ease of deployment, and the ability to share all that data in real time are some of the key attributes of wireless networks. You can see a list of some of the customers that we have that are using this equipment. You can see in the large graphic that all this equipment works together, all brought together by that software. So the lone worker scenario and the confined space scenario that Michael spoke about, as well as the drilling applications and the refinery turnarounds, all of that equipment can all be aggregated all in real time onto a single piece of software that stores the historical data and that can send alert notifications as necessary. All of it ties into one pervasive sensing network specifically designed for oil and gas systems. That's all I have for you today. I think we're going to move, I'll pass it back to Stephen, and I think we're going to probably have a little bit of time for questions and answers.
Thank you, Jan. Thank you for that. Yes, we do have a few minutes to kind of go over some questions, and yes, I did receive some excellent questions along the way, and thank you for submitting them, but keep them coming, and because, I know we probably have a lot of experts on the line, and they have a lot of detail-specific questions, so send them our way. Let me fire the first question off to Michael. I know we talked a lot about kind of the wireless solutions, and there's a lot of monitors maybe out in the field, but so what happens when signal is lost or a battery goes dead? What does the remote monitor show?
So, thank you for the question, Stephen. These are two slightly different scenarios, but what's in common between them is the fact that the remote observer will be able to get the information, get the notification that the instrument is out of the range, is off the network, And if the battery on that instrument dies, then the notification is also going to show on the remote screen, whether it be the portable mini controller, the EchoView host that we talked about as it pertained to the confined space entry scenario, or whether it be the ProRay real-time wireless safety system, which is used for larger applications in the lone worker scenario, as well as the potentially the drilling and the fence line monitoring scenarios that Jan covered today. So in any case, regardless of whether a monitor is in alarm, not an alarm, online or offline, the remote controller, either the mini controller or the ProRay Guardian screen, are going to show what is going on in real time.
Excellent. Thank you so very much, Michael. Let me direct the next question to Jan. During a refinery example, you showed remote monitors. Is the remote monitor single gas only, or can it be multi-gas?
Yeah, that's a good question. So the answer is really it's both. So the particular one I showed in that refinery was using in New Jersey is a multi-gas detector, so up to 5 separate sensors in one box. That's how they chose to deploy. I believe I had the list of gases up there, but I believe they had 3 to 4 sensors on each particular detector. So that's how they chose to deploy it. So you could do up to 5 gases, up to 5 sensors, or as I mentioned in kind of the last slide, you could use a combination of those multi-gas detectors as well as the single gas mesh detectors, and have all that information being pushed back to the same piece of software. Again, you can see the multi-gas and the single gas all on the screen all at the same time, that they work in conjunction with each other.
Excellent.
And from the portable equipment standpoint, it's also a similar situation. We have both single gas and multi-gas wireless monitors, the ToxRay Pro family of single gas monitors, and the Multiray family of multi-gas wireless monitors that can be used on the Ray Systems ProRay Guardian wireless network, and offer a very wide variety of covered and detectable threats.
So actually, Jan, going back to your previous question, and this is a follow-up question, is MeshGuard only single gas?
Yes, so the particular product that for the drilling application is a single gas product. However, we have multiple, you can choose which gas that is. I think we have 7 or 8 different flavors of toxic gases and oxygen and flammable gases. So each detector is a single point of detection for one gas. However, again, they could all be integrated. You could have, for example, on those drilling rigs, they typically have H2S, LEL, and SO2 all reporting back to the same controller.
Great. Thank you for that, Jan. Just to kind of remind on time, we do have a couple of minutes left, but we have a good number of questions to go through, so let's see how many we can bang them out. Michael, what is the time between bump tests or calibrations of the remote sensors? Is it monthly or is it weekly?
So it's a very good question, Stephen. We encounter that question very frequently from different groups of customers in different industries. Our general recommendation, and it's an industry-wide recommendation, that gas monitors, portable gas monitors, be bump tested prior to each day's use.
Excellent, thank you. Another question for you, Michael. Are the lithium batteries rechargeable, or do you have to replace them when dead?
So we use different kinds of batteries containing lithium in them. We have lithium-ion batteries that are rechargeable, and most products that we talked about, the Multiray family of products, the ToxRay Pro family, and they have lithium-ion rechargeable batteries. The EchoView host mini controller and the MeshGuard systems, they have lithium batteries that are not rechargeable. They last for a sufficient period of time. And we use also our older instruments. Some of them have nickel metal hydride rechargeable batteries as well.
Thank you. Let me move on to some software questions, ProRay Guardian in specifically. let me direct this to Jan. Are you limited to one central monitor running the ProRay Guardian software? Or can more than one computer get the data in real time simultaneously? For example, like a central control room and the safety resource center.
That's a good question. If I understand it right, so the detectors will always report back to one computer. So from a wireless standpoint, all the data is being filtered into a particular computer. Once the data is on the computer, it can be shared in real time with any number of other computers. So once you have that, the only requirement for that is that you have to have that particular computer has to be on a network. So you have to plug in an Ethernet or have to be on a Wi-Fi network. And once that data is on the computer, again, it can be shared in real time with as many computers as necessary.
Oh, that's excellent news, and that's definitely good to know. And a follow-up question to that is how fast or at what frequency does the ProRay Guardian software get updates from the monitors?
So that's a good question. It depends on which monitors. Some of the mesh networking products are they're user configurable of how often you want them to send data. And once that data comes in, it appears in the software in real time. So every time the remote monitor sends a piece of information, it'll show up immediately in the software. Now we have some of the other systems, some of the area array and the multi-gas instruments that we discussed. Those are being pulled by the software. The software is actively requesting the data from those detectors. And again, that's a user configurable setting within the software. So I believe it can go down to as quick as 1 second or as high as, I believe our default is 30 seconds for our mesh networking products. Again, all user configurable based on the application.
That's good to know, and we can definitely customize it any way that we will want to use it to be. So at this moment in time, I would like to thank our attendees for taking the time out of your busy schedule to join us on our webinar today. Please do not hesitate to contact your Ray Systems sales representative or our distribution partners with any unanswered questions. We hope the information from this webinar will be beneficial to you, and we look forward to hearing from you. Thank you for joining us today.
Thank you very much for your time.